Hey there. Today I want to talk about misconceptions of variables. Now, it's very possible that in this video series, I'm going to identify an incorrect mental model you have, right? I'm going to pinpoint a way you think about variables that's incorrect. And when this happens, if it happens, I don't want you to feel bad. I actually want you to feel a little bit excited. Because as a software engineer, it's very important that you always are questioning your own understanding of something to see if it's as true as can be. Right? So hopefully, this video series will give you a few insights, tweak your understanding a little bit so that you will have less confusions in your code, less bugs. All right? So the first question I want to ask is, how is it that we should conceive of variables? How should we imagine variables? Like, what metaphor should we use to think of them? Now, this is crucial because depending on your metaphor, you're going to treat them differently. Here's an example. Let's say, someone tells me they have a trampoline in their backyard, and I've never heard of a trampoline. And I say, "What's a trampoline?" And they say, "Oh, it's like the ground." How am I going to behave? I'm never going to, belly flop onto the trampoline because I think it's like ground, right? But imagine if they said, "Oh, it's a big, bouncy, soft, springy thing." Then I go, "Oh, trampoline, it's like a big, soft, bouncy, springy thing. Okay, I can jump on it," and I'll behave differently. In the same way, how you think about variables really matters. Okay, so I want to start off. By the way, this screen may be a little confusing to you. I want to point it out. Right here is our code. We're going to write code here. Here's me. Hello. Here is a little terminal. We'll console log some stuff. And here is a video I've made to kind of help walk through these different metaphors. So let's start off. The way most people conceive of variables starting off is they imagine variables as a container. Right, so let's just imagine that. Let's say we define a variable called marker1. Okay? It's a container. Seems reasonable. Okay, and what do we put in that container? Let's put in that container red marker. Okay? So now we have a variable containing something. If this metaphor is correct, we should not run into any problems thinking of variables as containers. But maybe we should think about them as something else. Let's test this out. What happens when you console log marker1? Red marker. Just what we expected, right? Console log it, out comes the red marker. So far, this metaphor of variables as containers seems to be holding. Okay? Let's keep going. Let's define a second variable called marker2. Okay? Now, here's what I'm going to do. I'm going to assign to marker2 the same thing, red marker. Right? Now, in JavaScript, there's only one string. So when you reference red marker, you're referencing one thing, and when you reference the string red marker, it's the same thing. There can't be two different strings with the exact same letters. They're the same strings. They're the same object. So here's the million-dollar question. If variables are like containers, then in this case, what happens? Right? How can a container hold two values? Which value does it go into? All right, so now you may notice that actually thinking of variables as containers doesn't really make sense because we can have the same value in two different containers. And just to be clear, these literally are the exact same number 4. They're not two different copies of number 4. There's one number 4, and it's both in marker1 and in marker2, and I can prove that because we'll console log marker1, and what will appear in marker1? I'm sorry. Let me save this really fast. Okay. And what will appear in marker 1? The number 4. We console log number 2. What will appear in number 2? Also the number 4. Right? So these two variables are holding the same thing, but we can't do that with containers in real life. So how should we change our mental model such that we're thinking of variables correctly? Right? Okay. How about this? How about variables? Maybe they're not actually containers. Maybe we should think of them as pointers, like a sticky note. All right, so we define marker 1, it's just a sticky note, and then we place that sticky note onto something, right? So just to be clear, that sticky note doesn't contain red marker. It just points to red marker, right? And what happens when we set another variable called var marker2 to the same thing? Very simple. We just take another sticky note and we put it on red marker. Right? Now we don't have this issue we were running into with one thing being held in two containers. We don't run into that issue because we just think of them as a sticky note, as a pointer. Both marker 1 and marker 2 point to the red marker. Right? And if I console log marker 1 and marker 2, we get red marker and red marker, right? Because when we say marker 1, it goes to red marker. When we say marker 2, it goes to red marker. It doesn't contain it, it just points to it. This is the right way to think about variables. And if you think about them as containers, you should update your mental model to start thinking about them as pointers. Okay? Now there's one more, another cool thing, we can have an infinite number of pointers to any value, right? So we can say marker 1, we could call it my fave marker, right? We could just have any number of pointers to a single John's marker. I can't keep up this fast typing. We can have an infinite number of pointers to a single value. Because it's not containers, they're pointers, right? Okay? Now, how does reassignment work? So check this out. Let's imagine that I have marker 2 is red marker. And then I say, you know what? We're going to change this. Marker 2, we're actually changing it to blue marker. What does this mean? What happens in this metaphor? Well, it's super simple. We have our blue marker, and we just take that pointer and move it from red marker to blue marker. We don't have to worry about the complexity of containers. It's just a pointer. Sticky note on something. You change the variable assignment, you move the sticky note, you put it onto a new thing. Okay? Super, super simple. Now, of course, if we console log marker, by the way, the console log color, it's just an extra thing I have that lets the console log be colorful, so it's easier for you to see. Console log marker 2, and it's blue marker because we've reassigned it. We pointed it to something else. We can do the same thing with any number. We can constantly take these variables and point them to different things. Okay? Now, there's one more thing I want to get to here. One more question, which is very important, right? And I'm going to show you a code sample here. Okay, var marker 1 equals red marker. Okay. Var marker 2 equals marker 1. Okay, so let's console log marker 2. Before I do that, I want you to make a mental guess at what you think it's going to be. What is going to appear in the console log when I console log it? Will it be the string red marker? Or will it be something else? Like maybe it'll be the word marker 1, right? What will it be? Let's test this out. Oh, I'm sorry, I forgot to save. Ignore that. Okay, it's red marker. Okay. This seems pretty reasonable, but here's what I want to make it a little challenging. We reassign marker 1 to something else, to blue marker. Okay. Now here's the very important question I want to ask. Will marker 1, so let's just go through this in the interpreter. First, we take the sticky note of marker 1, we put it onto red marker. Then we set marker 2 to marker 1, and it's not exactly clear how this works. Somehow, maybe the sticky note's on the sticky note or the sticky note's on the marker. Then we change marker 1 to blue marker. Okay, so here's the question. Is marker 2 now will this console log red marker or blue marker? What will be logged when I console log this? Red marker or blue marker? Red marker. Now, why is that? Wasn't marker 2 pointing at marker 1? And didn't marker 1 change? So shouldn't marker 2 also change? This is a misconception of variables. Let's look what happens. We have a red marker. We apply, oh, I'm sorry, we have different names here. Let me name these variables. My fav marker. We apply my favorite marker to red marker. Then we have a variable called marker 1. And we set it to my fav marker. Okay. Now, here's the question. Where does the sticky note go? Does the sticky note go on a sticky note, or does the sticky note go on the marker? Goes directly on the marker. Okay, goes directly on the marker. Goes directly on the value. Now, okay, so now when I change my fav marker to something else, does the marker 1 sticky note change? No, of course not. We have an object, we put one sticky note on it, and then here's the reason why we don't put sticky notes onto sticky notes. Because in the interpreter, whenever it sees a variable, like let's say I make my fav marker equals red marker, and then we say var your fav marker equals my fav marker, what actually happens in the interpreter? Something interesting happens. Whenever the interpreter sees a variable just hanging out in the world, it actually goes and it replaces it with the value of that variable. So at runtime, here's what happens. The interpreter goes, oh, my favorite marker, okay, sticky note equals red marker. Put this sticky note onto red marker. So now whenever you say my fav marker, I'll just replace it with red marker. Okay, var your fav marker, make a new sticky note, call it your fav marker. Okay, now it sees this and it says, oh, this is a variable. So what is this variable pointing to? Oh, it's pointing to red marker. And then the sticky note assignment happens. Variables cannot point to other variables. Whenever the interpreter sees a variable just hanging out, behind the scenes in your code, it replaces it with whatever that variable is pointing at. All right, variables at runtime, variable names are replaced with whatever that variable is pointing at. Okay, so this is the key rule. At runtime, variable names are replaced with whatever that variable is pointing at. Variables cannot point to other variables, because when I say your fav marker equals my fav marker, at runtime, it goes, okay, sticky note, my fav marker, pointing to red marker, good. Sticky note, your fav marker, pointing to, what does this equal? Pointing to red marker. That's what the interpreter does. At runtime, variable names, like this, are replaced with whatever that variable is pointing at. It's literally in the code replaced like this. And that's why the variable gets assigned directly to red marker instead of going onto the sticky note. It's directly assigned to red marker. Okay? So that's why if I change like this, if I say my fav marker equals red marker, so now my favorite marker is pointing to the red marker. Your fav marker is pointing to my fav marker. At runtime, it goes, this is red marker. Okay. Then, at runtime, this my fav marker sticky note just goes to a different marker. Right? So that's why if you have a variable assigned to another variable, it's not actually stuck to that variable. It's stuck to the value behind the variable. Because at runtime, variable names are replaced with whatever that variable is pointing at. Okay? Those are a few misconceptions of variables.